In today's video, we're going to look at section 8-6, solving rational equations and inequalities. So let's get started. Now, we're going to solve 9 over 28 plus 3 over z plus 2 equals 3/4. And to check your solution, all we have to do is really with a calculator. So now, when we deal with rational equations, we want to make sure we try to get rid of our denominator. But first, we need to establish that z cannot equal -2, because that would make the denominator 0, and we can't have it. So we just got to establish that. So what we want to do is find the greatest common, or the least common denominator, and that would be, so through all our practice, we can find that the least common denominator is 28z plus 2. And what we're going to do is we're going to distribute this to everything. And so what ends up happening is things cancel out. So we get the 28s on the first one cancel out, so we're left with 9 times z plus 2, so we get 9z plus 18. And then the next one, the z plus 2's cancel out, so we're just left with 84. And on the last one, 28 and 4 reduce to get 7, so we have 7 times z plus 2 times 3. So that simplifies down to 21z plus 42. And from there, now we just solve for z. So combine like terms, so we get 9z plus 102 is equal to 21z plus 42. And now we're just going to solve. So I'm going to subtract 9z from both sides, while also moving this 42 to isolate the variable. So we end up with 60 is equal to 12z. And then solving for z, divide by 12. So z is equal to 5. And from there, I'm just going to grab a calculator, plug it in, and we get 9 over 28 plus 3 over 7. And after plugging in, we see that it is equal to 3/4. Okay, so let's do another one. This one's a little bit trickier. So we have r plus r squared minus 5 over r squared minus 1 is equal to r squared plus r plus 2 over r plus 1. So in this one, the common denominator, well, once again, r cannot be equal to plus minus 1, because that will make one of the denominators or both couple 0. All right, so now the common denominator, the least common denominator, is actually just r squared minus 1. Okay, this is because r squared minus 1 is actually just r plus 1, r minus 1. Okay, so now we're going to distribute that onto all three terms. So on the first one, nothing cancels out, so I'm actually left with r cubed minus r. The second one, the r squareds cancel out, so we're left with plus r squared minus 5. The r squared minus 1s cancel out, so. And then the last one, only the r plus 1s will cancel out. So I'm left with, after I do all the foiling, I did all that on a separate sheet of paper, I get r cubed plus r minus 2. Okay. So from there, we're just going to move things around. So notice we subtract the r cubes are going to cancel out when we subtract one. Okay, so I end up with r squared minus r minus 5 is equal to r minus 2. So we're going to move things around. So we're going to subtract r from both sides, and we're going to add 2 to both sides. All right, because since it's quadratic, we got to get it set equal to 0. So we have r squared minus 2r minus 3, and that's equal to 0. Okay, so now we factor, so we get r minus 3 times r plus 1 is equal to 0. Solve them, we set both equal to 0. So r minus 3 equals 0. R plus 1 is equal to 0. So here in the first one, r will equal 3, and the second one, r will equal -1. Well, we've already established that r cannot be -1, so we have to throw that one out, and then we plug the 3 in to make sure it works, and we find that r can equal 3. So in this one, we only have one answer, r is equal to 3. So now we have an inequality. Solve 1 over 4a plus 5 over 8a is greater than 1/2. So in this case, what we want to do is actually treat it like it's equal. Just solve it like normal. And there's a few more steps afterwards. So our common denominator. Okay, so first, again, establish what a cannot be. So a cannot be equal to 0. We're going to need that later. This is going to be even more important. Okay, so we're going to solve it like normal. And greatest common denominator would actually just be 8a. So we're going to multiply everything by 8a. And then we're going to distribute. So we end up getting 2 plus 5 is greater than, well, let's just say equal, because that's how we're just going to treat it for now, is equal to 4a. All right, so we just end up with 7 is equal to 4a. Solve for a, divide by 4. So we have 7 over 4 is equal to a. So now we have two different numbers here. We have 0 and 4 sevenths. So I'm actually going to create a number line, because we have to. This is what we need to do. So we have our first number, 0, and we have our next number, 7/4. So we have to test all three different intervals. So we're going to test this interval in green, the second interval in blue, and the third interval in red. So in green, I'm going to just try a number, -1. Okay. Oh, that's supposed to be green. -1, sorry about that. And the second one, in the blue, I'm going to try just +1. And in the third interval, I'm going to try 2. So when I plug all this stuff in green, now I'm going to plug in 1 over 4 times -1 plus 5 over 8 times -1. And I'm going to check if that's greater than 1/2. And after plugging everything in, I end up with -7/8 is greater than 1/2. And that is not true. So no, that one doesn't work. Okay. So then I'm going to try with 1. 1 over 4 times 1 plus 5 over 8 times 1 is greater than 1/2. And after I simplify, I end up with 7/8 is greater than 1/2. And that is true. Okay, so the blue works. And now I'm going to try red. So I get 1 over 4 times 2 plus 5 over 8 times 2. And I'm going to see if that's greater than 1/2. And I end up with 7/16 is greater than 1/2. And I know that is false, so no. So my only solution is when it's between, is the interval that works. And it's that interval. So my answer is A lies between 0 and 7/4. And that is my solution. Okay, so let's do another one. 1 over 3b minus 2 over 5b is less than 1/15. So once again, b cannot equal 0. So common denominator would be 15b. So when I distribute, I end up getting 5 minus 6 is less than b. So -1 is less than b, or equal to, or remember we said that, we'll just treat it as an equal sign. So my interval is from -1 to 0. So in my intervals, I'm going to try here at -2. From here, I will try -1/2. And the third one, I'm just going to try 1. Okay, so when I plug in -2, I end up with 1/30 is less than 1/15. That is true. In green, I end up getting 2/15 is greater than 1/15, that isn't false. And in the last one, I ended up negative 1/15 is less than 1/15, so that is true. So my solution for this one is on the outskirts of this. So it is less than -1 and it is greater than 0. So B must be less than -1 or B must be greater than 0. Okay, so remember, I'm just plugging in those numbers into the original equation to see which one works. So the next one, same exact thing. In this case, x cannot be equal to 1. So our common denominator is 6 times x minus 1. So if 6x minus 6 plus 30 is equal to 7x minus 7. So 6x plus 24 is equal to 7x minus 7. So moving things around, I'm going to subtract 6x from both sides, add 7 to both sides, so I get 31 is equal to x. So our number line, we have our 1 and we have 31. So our intervals, our test numbers. First I'm just going to try 0, then I'm going to try 2, and I'm always going to pick the easiest ones I can do, and then I'm going to try 32. So when I plug in 0, I'm going to end up with 1 plus -5, and I'm going to see if that's less than or equal to 7/6. And I get -4 is less than or equal to 7/6. True. Next, I'm going to plug in 2, and I end up getting 6 is less than or equal to 7/6. That is false. Keep in mind, all I'm doing is plugging things into the original. And the last one, when I plug in 32, I end up with 36 over 31, and see if that's less than 7/6, and that is also true. So once again, my intervals that work are less than 1 and greater than 31. So we have x must be less than or equal to 1, or x must be greater than or equal to 31. All right, so it's a little bit of work. Okay, and remember, we can't actually have 1 as an answer, so we actually have to get rid of that, or else it will fail. So we get rid of that or equal to part. So there we go. So